Have you ever wondered why when we push a pen like this, okay, it eventually comes to a stop? Or why when we roll a pen, it eventually comes to a stop? Not just a pen, you can take a coin. We push the coin and we see eventually the coin comes to a stop. It stops eventually. Let me also show you this fidget spinner. Okay, so we have this fidget spinner. We rotate it, we spin it, and we will see it slows down and eventually comes to a stop. Okay, you may try this with anything that you see around you. Okay, you can try with the door. You try to push a door. Okay, please do not slam the door, of course. Okay, try to push the door and we will see the door eventually comes to a stop. Why is it that when we push a ball, whatever kind of a ball it be, a tennis ball, basketball, TT ball, whatever it be, okay, I've made a small paper ball over here. So why is it that when we push a ball, it rolls for some distance and eventually it comes to a stop? Now, why do you think all of these things, be it rotating, be it rolling, or be it sliding, okay, all of these things, it comes to a stop? Why do you think it comes to a stop? Now, the answer lies in the topic of the day, which is force of friction, or which is also called a frictional force. Now, before we jump to the definition of force of friction, okay, let us give a look at two effects of force. All right, effects of forces, we've already done this. The effects that a force produces. Okay, so let us look at two of the effects, which is effect number 2. A force can stop a moving body, and effect number 4. Effects 2 and 4. A force can slow down a moving body. So as you saw in the examples that I gave previously, the coin when being pushed, it was coming to a stop. The pen when being pushed, it was coming to a stop. Also the fidget spinner, while spinning, it slowed down and then it came to a stop. So to slow down a body or to stop a body, there needs to be a force applied. There has to be a force which when acts, okay, what happens is the body slows down or the body stops. This force which slows down a body or stops a body which initially was in motion is what is called force of friction. Now say for example, you are standing over here and a ball is rolling towards you. This ball is rolling and coming towards you. Okay, now what you want to do is you want to slow this ball, slow the speed of this ball, or you want to stop it. Okay, so in order to slow it down or to stop it, what do? We apply a force, or you apply the force in the opposite direction like this. Okay, so to say, you want to oppose the motion of this body. Alright, now similar to this force that you are applying to oppose the motion of this body, okay, our force of friction also slows a body or stops a body. So to say, our force of friction also opposes the motion of the body. So to give a proper definition of force of friction now, force of friction is defined as the force which opposes motion. Opposes motion meaning it either slows down a moving body or brings it to a stop. Alright, so opposes motion means that, remember. And always acts between the two surfaces in contact. Now we have to see where does this force of friction act. Okay, like let me bring this coin again. So I have this coin. Okay, I'm pushing it. This coin slides and eventually comes to a stop. So we've come to know now that this coin comes to a stop because of force of friction. Now where is the force of friction acting? Force of friction, remember, is acting between the surface of this coin, the lower surface of this coin, this lower surface, okay, which is sliding over the paper. So the force of friction here is coming into play between the lower surface, the bottom surface of the coin, the lower surface of the coin, okay, and the surface of this paper. All right. So whenever two bodies, okay, are in relative motion with respect to each other, relative motion meaning one body is moving over the other body, all right, or could be rolling over or sliding over the other body. All right. So whenever one body moves, that is slides or rolls over the surface of another body, force of friction always acts between the two surfaces in contact. Okay. So I again repeat, the surfaces in contact in case of this coin sliding is the surface of this paper and the surface of the coin itself. All right. Let us also look at this example given in the book. A boy over here is trying to push this big box over here. All right. So this boy is trying to push the box in this direction. So force applied by the boy is in this direction. So the boy wants the box to move in this direction. So he's pushing the box in this direction. So, and this is the ground. All right. This is the floor. Now, where does force of friction act? The force of friction is acting between the two surfaces in contact. Now, where are the two surfaces in contact? It's the lower surface of the box and the surface of the floor. Okay. And of course, remember, force of friction always acts in the opposite direction because it wants to oppose motion. Therefore, remember, this is how force of friction is defined. It is defined as the force which opposes motion and always acts between the two surfaces in contact. Since force of friction acts between the two surfaces in contact, so therefore force of friction is a contact force, remember. Okay, so force of friction is an example of contact force.